Hi there, this is my Scaffolded Exercises Winter 2019 end of quarter video. So imagine an intermediate developer looking to improve their programming abilities. They've already completed Code Academy or something equivalent, they've practiced building some projects independently, and they've even looked into industry standard libraries and frameworks like jQuery or React. Still, they don't have the structured exposure to learn or practice with professional patterns. So there are a variety of learning methods that could help them with that, but they still don't offer real exposure and practice with professional code in an authentic environment. So if a learner works through more tutorials, they won't be in that learning environment that's, web, that's live. And if they build more personal projects, they'll still be constrained to their intermediate understandings and patterns. If they look into more libraries and frameworks, they still may not understand the professional patterns to best utilize these tools. So how might we expedite the process of learning to understand and write professional level code for motivated learners? So during winter quarter, I tried to get closer to answering this question. I believe that by giving learners process management scaffold and technical skill coaching, they will be able to navigate through complex code bases, understand professional programming patterns, and recreate those patterns in an authentic learning environment. In other words, on the web and not just in a sandbox tutorial. These hypotheses come from a quarter full of need finding, user tests, and system prototyping. So the first part of my efforts that really shaped the rest of my work from this quarter was need finding. I spent time creating an exhaustive list of everything a user needs to know in order to be able to recreate the click and drag XKCD comic example. Let me show you that right now. So you've probably seen it before. It's just the click and the drag. Simple, but it goes on forever. Top, bottom, left, and right. So this list includes technical understandings like frames of reference for positioning an item on a web page, all the way up to conceptual level understandings. Why is a double for loop used to place tiles on the screen? By creating this list, I was able to better grasp possible characteristics needed to address these obstacles. So here's a little short example, of kind of me ideating through this list of what's required. And this is just a few of them. So a huge component in building that list of obstacles and designing characteristics to address them was user testing. I ran some form of user test every sprint due to my need to understand what a user needs to write professional level code, what they lack, and what their possible characteristics are that can bridge that gap. Two things that really improved the quality of my user test was creating really specific outcomes and updating my user class definition. And so I spent a lot of time in terms of study design, improving these things. So the first thing was the study design intermediate outcomes. So I created a mapping so that each major step in a user's progression through scaffolded exercises had a measure attached to it. So these intermediate outcomes allowed me to measure where a user was at each point in scaffolded exercises so I could understand which parts of the exercises were and were not as effective. This right here is an example of pre and post isopleth expectations and how I'm measuring that. I worked on this with Gobi in Studio a few weeks ago. So the other big thing, like I mentioned, that changed the quality of my studies was redefining who I was going to be testing on. For now, I'm going to continue working with a more advanced intermediate web developer to avoid having to teach basic JavaScript concepts and basic library syntax. So before, I was working with people who had basic understandings, maybe had built small personal projects, and now I'm working with someone who has kind of a deeper conceptual understanding of JavaScript and its usage for web development. Finally, I started to test some low-fidelity system prototypes towards the end of the quarter. Even though they were kind of smattered in, I had a more full-fledged system prototype by the end of this quarter. In my final week, actually, of this quarter, I also started trying to explicitly map existing literature to my system design in order to both justify and improve my design decisions. So I ran user studies to work on those three main parts of my project, macro structures, obstacle surfacing, and system prototyping or system design. So macro structures are exercises that help learners get a high-level understanding of different components of a program. Whereas isopleth is for creating a really high-level mapping or mental model of a program, macro structures zoom in a little more, asking questions about the specific code to encourage code reading and sense-making on a more granular level. So I ran 2 distinct rounds of testing for macro structures, adding questions for event listeners and updating my ideal outcomes in the second round to get a little bit more clarity on what was working in terms of the questions and what wasn't necessarily getting at the core of what a specific part of a program was doing. So this really quick is some example pseudocode from a study. There are definitely shortcomings, so I didn't ask for enough specificity in the pseudocode, and I think a lot of the reason is because I didn't have specific enough outcomes to really understand what a user understood. So sometimes the pseudocode wasn't actually super helpful in pinpointing just the level of understanding. I also didn't use isopleth in this round of study, which was because it increased the time needed for the study, but it also increased the time needed for a user to get comfortable enough in the code base to start making constructive progress on the macro structures. So I actually think that it might be more time effective in the future to use isopleth, which I did end up using later in the quarter. We'll talk about that in a minute. So here are some outcomes from macro structures. These are a few quotes from users, and I learned a lot about what a user needs to be able to understand functions and different parts of a program and how different components interact with one another at another level. So it's not just at this conceptual level that a user is hopefully understanding these connections, but it's really on a more specific level. How are variables being passed around? What function is calling other functions? That kind of stuff. So I discussed this a little bit earlier, but I'm now able to enumerate a lot more of the obstacles a user may face when going through a series of exercises in trying to recreate professional level code. So during these studies, to try and get that exhaustive list of obstacles, I tried to give a user every piece of information possible about the example. So I walked them through every line of the code, I answered any questions that they had, and then I asked them to recreate the code and noted places they still got stuck. This was helpful for adding to my list, but it was really difficult because I wasn't using the most effective user class possible. So I think that a lot of the information that I was giving actually was lost on the user because there was just such a huge barrage of information. And there wasn't that conceptual basis to kind of absorb that information in the context of the XKCD example. So additionally, the way that I walk users through the code line by line isn't necessarily how people always process. And there wasn't enough time to allow, or I didn't make enough time to allow for individual exploration through isopleth or macro structures or whatever it may be. Still, I gained a lot of insight into all the things a user needs to write professional level code. And it was really informative for my system prototyping. So most recently, I've been working on system prototyping, like I said, and so using a combination of isopleth, macrostructure exercises, and microstructure, or more line-by-line, really granular exercises, I've constructed a system to scaffold learners to recreate XKCD. I'm doing this actually on a slightly modified example of XKCD that removes a lot of the CSS logic, which I can show you here. So there's a breakpoint, which is not going to be helpful. So instead of having those frames of reference, like you can see here, where positioning gets kind of confusing, it's just all of the tiles are being loaded on the screen. Earlier in the quarter, I was actually using an even simpler version with just one tile, but it took out most of the interesting parts about how different tiles are loading. So I added that back in this kind of larger map here. So as a user goes through isopleth on the modified example that I just showed here, afterwards they're asked a series of questions that I'm thinking of as like pre-isopleth test questions so that I can gauge a learner's understanding from isopleth before they actually start using scaffolded exercises. So if they can't answer any of the questions that I prompt them with, I take note of that and I move on. So then I use a combination of macrostructure exercises, microstructure exercises, and isopleth to create an environment. Then I create that series of exercises, and then, I use Chrome Developer Tools, Teletype, which is an add-on package, and Google Docs to create an environment that simulates a live updating site if you wrote code in the console, an interactive note-taking space where questions appear at different steps in your progress, and variable value tracking and surfacing, so that code can be stepped through, interacted with, changed, and you can kind of see that all being mapped to the variable values as well as the image that's showing up. So it's definitely not a perfect system. I have to do a lot of fiddling, especially in Chrome developer tools, as a user picks different exercises to work through, but it does a job in terms of starting to visualize variable values and the effect of changing code. So after setup kind of in mind before someone actually starts picking their exercises to go through. I have them go through macro structure exercises, the ones that I tested on earlier in the quarter, and I have them do this on the event listeners within the XKCD code that kick off the click and drag event. And I chose to have all users do the macro structure exercises on the event listeners because I think the event listeners are a valuable entry point into a lot of JavaScript interactions, right? They most often kick off the chain of events that actually make the interaction happen. And they can also be programmatically detected, thus this structure can hopefully be applied across arbitrary examples as we try and generalize the work of scaffolded exercises. So then the meat kind of scaffolded exercise is the toolbox of exercises that a user can select from to move through the code. Between each exercise that they select, they're asked what they feel like they understand and what they still have questions on. And the idea with this is that they can do kind of a self-reflection that allows them to pick the best exercise based on their points of confusion. However, the big part of my system that's still missing is some trigger to note when a user should try and recreate the code. Because right now I'm wizarding that step where I'm intervening at a point and asking a user to recreate the component of code that they have been working through using the exercise that they selected. Because I've been trying to get at the specific tougher parts of the code, and because of time constraints of the study, I have been wizarding that, but that means I'm still missing scaffolds where I can see a learner decide for themselves when they want to recreate a certain component. So this has been the most kind of successful study, this system prototyping study has been really successful insofar as that users are actually writing code, right? So I've only tested on 2 people so far, and I definitely need to refine my system prototype based on that, but I believe that the combination of all of these component exercises and the user flows that I've been working on throughout this quarter and previous quarters has shown itself to be really effective in helping learners write professional level code. So here's a few quotes from my 2 user studies so far. I also had someone recreate event listeners, be able to recreate event listeners so that the values that would update the screen were console logging, and had someone else try to write update, which wasn't perfect, and I could get more into that, but that is actually shown in my documentation, and I'm out of time. Anyway, next quarter I plan to focus on reading my exercises more concretely in literature and extending my exercises to fill in the remaining gaps I discussed in terms of process management, scaffolds, and then any remaining kind of technical skill acquisition techniques that seem to be missing based on watching someone try and write update. And once I'm more concrete in those exercises, I plan to build a slightly more high fidelity system to run more effective user studies. Thanks so much for listening.